Okay, whoops, it looks like I got went a little too far with the last video, so I'm backing up just a little bit here. So, so here's an SMZ that's well laid out, that's flagged in very nicely. The contractor knew where to go and where to stay out of. Here it wasn't laid out quite so well, so the contractor ended up moving into there, and next thing you know, you got bare mineral soil right down to the creek, which is bad. Okay. Here they probably pulled out a few trees, but they kept about 50% of the shade. That's perfectly fine. And here they actually pulled out a little bit too much, and so you're starting to get sunlight down into that stream there, and it makes it too hot on a hot summer day. Great SMZ, okay, 50 foot on either side. Here they went right up to the edge, debris down into the creek, bad stuff, okay, don't want to do that. Here's an ephemeral channel, and they just went up, pretty much to where the channel looks like it pretty much stopped, and and just kept the that area kind of shaded in there. Here's a BMP inside an SMZ, and so here's the creek right here, and notice that they put a little check dam right in there to pond that water up to keep it from going directly into the stream. So this holds that water back. Compare that to having a stream crossing going through your SMZ and just letting the water have its way. That is serving no purpose. This SMZ is not able to capture any of this silt or any of that soil that's being eroded here. This is going to be the number one primary spot for stream pollution because of the logging. These areas always end up being the number one. Right? So certain things you can and cannot do in SMZs, applying herbicides, burning, stuff like that. Okay. So I'm going to move to one last one here, and that's on stream crossings. And thing that's important to know about stream crossings is you can have temporary stream crossings. The Forest Service will provide you with bridge mats. You can borrow them and lay them out. So you do not have to have a full-blown bridge or anything like that. We talk about this much more in the soils and logging course, and we'll also talk about it in the forest management class a little bit more too. But I just want you to be aware that building bridges across streams, temporary bridges, is a very, very good solution, okay, rather than just plugging a road right through there. So there's lots of different options for that, and good and bad, and we're not going to get into all the details for that. But even if you got a ditch right by the road, you can have your logging trucks go over that bridge mat there. Excuse me. I wanted to move down into the culverts. Okay, culverts are pretty important for you as part of a planning process. If you're trying to put a road in for somebody, you can put in temporary culverts for logging operations and then pull them out when you're all finished. But more often than not, you're planning on keeping them in a permanent road. So the thing that's important to remember is don't ever use an undersized culvert, especially if it's going to be a permanent road, because it will blow out. You plan for the largest type storm event when you're planning the culvert size. Another thing to remember is that if I need a 30-inch culvert based on my specs, two 15-inch culverts will not do that, all right? So don't put two 15-inch culverts in and think it's going to replace a 60-inch culvert or 30-inch culvert. It won't, okay? So you'd use the charts that I'm going to be showing you here. Gets a little bit into how you place the culverts in. Basically, you lay it on the stream bottom. Okay, let me flip this a little bit. So you lay it on the stream bottom. You don't lay the culvert up above the stream and expect the water to run up and into it. It's got to be right on the stream. and it's got to be at the same same slope as the stream. You have a little bit of you have it stick out a little bit on the downhill side, and you secure it with riprap and get it vegetated. Okay, what you don't want is this thing to be sitting 3 feet up in the air and dropping water down onto the soil, because it'll start eroding it away. So there's temporary culvert sizes, okay, based on the average channel width and the channel depth. So that's if you're doing a, if you're doing a logging job, you can go ahead and use these guides to figure out what size culvert you're going to be using. However, if you're going to be putting in a permanent culvert, you probably want to use this chart here, and it's not as complex as it really looks. All right, so these C ratings, they're just kind of best guess of how much runoff you're going to get. The higher the number, it means that every raindrop, if it's 1, means every raindrop that lands on there is going to end up going through that culvert. Okay, 50 is 50% of the rainfall that you get is going to go through that culvert. All right, so that's kind of what these mean. This is probably, for most of our forested areas, you could either use steep or moderate slopes, but I would choose probably these lower numbers for each one of these major sections here. Okay, so basically what you're doing is you put a dot on the map where you want to put your culvert, and you figure out what is the drainage area around it. Okay, so that's why we did that practice with the calculating the acreage around certain points on maps. And so once you do that and you figure out your acreage, your drainage area, this is basic on a super duper rainstorm intensity of 2.5 inches per hour rainfall. And then you also look at the steep, what does the area look like? Is it steeply sloped? Is it moderate cover? Is it moderate slopes with dense cover? Okay, those sorts of things. So again, you would use kind of probably around here in forested areas, you could use kind of a combination of these sorts of things to help you out. So let's do a real quick example. Okay, so this look familiar? This is the excuse me, the Fowler Forest for some of you who worked out there this past semester. That's the bridge there, the first bridge crossing that was all kind of hard to walk over. So you're kind of familiar with how steep that is and the amount of water moving through there. So that's the point on the map. That's where I'm thinking about putting the culvert. I might want to replace that bridge with a culvert. Okay, so I went ahead and just drew a line around the area, or created a polygon. Turned out that it's 128 acres that is draining into that culvert. So let me go back to my table here. 128 acres is going to be somewhere between 100 and 150. So it's going to be somewhere in these two areas. So I just have to kind of decide which C column I'm going to use. So I'm probably would just say, all right, it's steep, but it's got dense cover, so it's probably going to be one of these two right here. And so I'll probably just pick the 60 and go, all right, it's either going to be, probably if I went with one 48-inch pipe or a 36 and a 36 and a 24, whatever was less expensive or whatever worked the best in that particular area, I'd probably go with one of these two designs right here. Okay, so you got to balance it because culvert is not cheap, and so you got to lay it, like I said, you got to lay it down into the stream channel. So it's probably going to be about 25 feet long, and for each of those culverts that you can be putting in there. So you got to kind of balance those sorts of costs there. But that's basically how you would go about doing it. For a test question, I would probably give you something like, oh, I got 40 acres and I want to use a C column of 0.6. All right. So I'll try to make it more straightforward for you, with that. But, I just want you to see how you use these charts. Okay. So again, so that's a really good way of sizing up your culverts. All right. Let's more or less what I wanted to show you with this manual here. Again, do not, make sure you got it vegetated. Make sure that you got it stabilized with rock. There, it's not stabilized at all. We see this way too often up in the mountains. That's just going to erode away. Okay, so it shows you how to build a good head wall and how to get the water out so it's not going to be eroding things away. It talks about fords and stuff like that. I'm not going to get all into that. But that's essentially some of the things I want you to get out of this in terms of water quality. How do we keep our streams nicer? All right. The last thing I wanted to point out to you is this Layman's Guide to Road Construction in the Southern Appalachians. This is a really, really great guide. And let me kind of get a little bit larger here. This was written by the folks at Coweta, and it basically has a lot of really good. So this book has a lot of really good dynamics, and you can see it was written by our friends over at Coweta a number of years ago, and then it was revised about 2005 with some really good information. But this is just an essential book for developing permanent road systems. All right, gives you some basic cost estimations. They're a little bit old, where you can get some general assistance in designing roads, road grades, what are the best grades for certain situations, how do you do the cuts on the upslope cuts and the fill slopes. Usually they're a 1.5 to 1 ratio versus a 2 to 1 ratio on the downhill side. And so just lots and lots of different examples of roads. That's that outsloped road I was talking about, where you, with no broad-based dips, you can do an inslope road and then put broad-based dips in them. That's an outsloped road with an inside drain and cross drainage, and that's an insloped road with cross drainage. Okay, so again, lots of different things that, a lot of stuff that we just kind of talked about, but in much, much more detail. What is best types of couplings when you're joining together culverts? What type of material works the best? Entering highways, you want to be as close to a 90 degree as possible. It's just all kinds of great ideas. And then the best times to build. All right. And then some of the, how do you obtain the materials? What's it going to cost you? Where are you going to get all that equipment? And, so then type of equipment that's going to be used in it. So during construction and then establishing regeneration. And what's nice about this is that they're actually starting to include, some of our native species as well in here. Switchgrass, and those sorts of things, are probably important to be included in this rather than just putting in orchard grass or creeping fescue, stuff like that. So it's nice to be able to have some native species involved with that. And so again, just a really good document for you to hang on to. I'm not going to hold you to anything in this document right now, but this is one, if your landowner is planning on putting any kind of road systems in at all, this is just a fantastic document to get them up to speed so that they become aware of what you have out there. Okay, so with that, I will let you guys go. You all have a great day.